again for the invitation and also for organizing such a great event. It's actually really great to see so many people here because there's so much enthusiasm around A/B tests. Yes, so before I get started with my talk, I actually wanted to do a quick survey to see who has actually run an A/B test before. Great, so I want to say more than half of the room have done that. Okay, so hopefully my talk today will offer something new to everybody in this room. So A/B test, on a very high level, is very simple, right? So let's say I have this registration page at LinkedIn.com, and it has this yellow button that I don't think is really driving people to click on it, right? It's not really driving registration rate. So what I do is I say, okay, what if I actually change that yellow button to a green button? Would that actually doing better? Right, so what I do is I actually start to divert traffic or part of the traffic into the green button, and while still keeping some of the traffic to see the old yellow button. And at the end of the day, I collect information in both buckets of users and compare them on metrics such as registration rate. So that is essentially the gist of A/B test. So the old version, which is the yellow button, is my control. And the new version, the green button, is my treatment. So the reason I'm going to organize my talk today will be around the three most challenging areas that I consider when you wanted to actually do A/B testing at scale. The first one is around the culture challenge, which I consider is actually the most difficult aspect when you wanted to do data-driven, when you wanted to be data-driven company in your company. The second aspect is how we can actually build an engineering platform that can actually handle that much data and that many experiments that's running on a daily basis. The third aspect is around education. How can we make sure that when people are designing their experiments and also when they are analyzing their experiments, they are following the best practices so they are making the right data-driven decisions. So why should we run A/B test? So I'm sure everybody who is in this room understands that A/B test is important. But my goal today is when you walk out of this room, you not only think that A/B test is important, it's also crucial and indispensable if you want to be data-driven in your company. Let me start with one example. Who does not use Amazon? Great. So everyone in this room can relate to my experience when I was buying a muffin pan for my son's birthday party. So when I add this muffin pan into my shopping cart, right after that, I actually was shown this module. Essentially, customers who bought this muffin pan also bought the following items. Right, this is such a common practice nowadays in e-commerce websites. I barely even noticed it. But back when Greg Linden at Amazon first introduced this idea, he actually ran into a lot of resistance. So why do you think the trade-offs are in terms of showing recommendation based on people's shopping carts? What are the pros and cons?
You can change your mind.
Exactly. The downside is that you may actually distract people. They may change their mind. They may actually not check out, right? So reduce conversion rate. So what are the pros? Yeah, you may actually sell more items, right? You can cross-sell more. So this is exactly what they were debating over. And at the end of the day, the HIPPO's opinion, the highest paid person's opinion, was to stop the project. So even though Greg Linden was forbidden to run these projects, he was actually able to push for at least an A/B test. And the results from the A/B test was so successful that there was an urgency to launch this right away because it was making so much money that they couldn't afford of not making that money. Okay, So you may be thinking, okay, the hippos may just not know what they are doing, right? They don't know what they're saying. Okay, how about ourselves? We are all experts in some domain, right? How about our own opinions? Here, I'm showing you another example. I'm showing you the Find a House widget on Amazon Real Estate, right? There are two versions, A and B. So every single time when a user clicks on this Find or Search button, revenue gets generated to Microsoft. So which version do you think actually was making more money? If you think it's A, please raise your hand. If you think it's B, please raise your hand. Okay, so majority of this room think that B is better. And I can tell you the result is that A was actually making 8.5% more money than B. So it's not just the hippos, right? Our own intuition is just not as good as you think it is. It's actually extremely difficult to assess the value of ideas. And that is precisely why we need to run A/B tests. Experimentation is actually the only way that we can prove causality. And that is why this is the only way that FDA, for example, accepts the drug to approve for drug efficiency. So we should use A/B tests to essentially assess the value of investment and also to guide product development. And most importantly, this is the most valuable way for you to actually get the feedback from our real customers. Okay, so then now we understand we need to run A/B tests, right? So what should we be A/B testing then? For that, I want to share another real example from LinkedIn that happened actually very recently. So when you go onto LinkedIn.com and you go to the profile page, we actually show you this one line of ads above the profile page, right? So at the end of last year, where we observed that there was a huge drop on the click-through rate on these ads. And keep in mind that the click-through rate is directly related to how much revenue this ad is bringing to LinkedIn. This drop was huge, it was more than 30%, right? So when we saw this, the team spent days trying to identify what went wrong. And it turned out that during a bug fix, it was unintentionally that there was 5 pixels was removed between the navigation bar and the profile page and the ads. And that 5 pixel cost us a lot of money and also a lot of resources just try to identify what went wrong. And this was all because there was no A/B test that was ran. So it not only cost us resources, but also cost us the money because it took us a while to actually uncover what went wrong. Imagine if we actually had an A/B test run for this release, we were actually able to catch this, and also we were able to limit it to a smaller set of members instead of the whole LinkedIn member. So what I'm trying to emphasize here is really that people are very used to use A/B tests in order to evaluate new ideas, right? When we are launching some new features on the UI, when we are redesigning our whole homepage, and also when we are changing the backend algorithms, right? We are all used to say, okay, let's do A/B tests. But how about platform changes, right? How about code refactoring? How about bug fixes, right? So when you are, and I hear this quite a lot, right? So when people are launching a new component for a platform, they were like, okay, this platform, the new component is so much better. It's faster, it's using less memory, and it's just based on a better and newer code. It's better to manage. And we've satisfied all the exit criteria, right? We've gone through the building process. We are ready to launch. No, not really. In a real data-driven organization, the final check, the final exit criteria should always be running an A/B test. And I will share this very interesting story from Amazon. So back when Amazon order pipeline was going to ship a new shiny pipeline based on their new app server. They spent months on it and they were ready to ship, right? But right before they were launching this new pipeline, they were asked to do an A/B test. So the results came back and there was a 2% revenue loss. Imagine 2% revenue for Amazon. That's a lot of money. So the team went back and dig into the code and found the bug, right? So they were ready to ship again. But no, you have to do another A/B test, right? So this whole process, back and forth, actually took 5 times before the final new pipeline was on par with the old pipeline that they were retiring. So it's not just the new ideas that needs to be A/B tested. When you are changing the code, when you are just re-implementing old ideas, they also may not be, the new implementation may not be as good as you think they were. So the recommendation really is that you should be running A/B test for as many things as you can, and you should be A/B test everything. Keep that as a motto. Okay, so since I'm at Coursera, I figured that I should talk about the difference between a startup and a bigger companies. So a lot of times when people are working at a startup, when they are thinking about A/B test, they usually were asking, okay, do we even have enough users to even run A/B tests, to even actually get meaningful results from A/B test? And luckily, the A/B test actually scales naturally with the number of users you have in for your company, right? Startups usually are looking for a bigger impact because when you're thinking about a large website, usually the components are well optimized, right? So startups are looking for a larger impact. And the example that I'm showing over here, right? So if you are looking for a site, the impact that is a 1/10 of 5%, you actually need 100% times more users to be able to detect that, right? So when you are looking for bigger impact, you don't need that many users to identify that difference. And the second crucial point, as I said, a culture challenge is usually the most difficult thing to change as the company grows. So at a startup, if you can actually establish that culture at the beginning, it can really benefit the company in the long run to be truly data-driven. Are we taking questions during the talk? Okay, so next topic that I will be touching on will be how can we build a system that can actually allow you to accommodate a lot of experiments and actually also be able to scale with the data that you're looking for as well. So if most of the people I imagine in this room haven't really built A/B tests, but maybe you have run A/B tests in your experience, in your current job or the past jobs. So you probably have noticed that when you are running an A/B test, there are essentially 3 steps that you have to go through, right? So the first step is really in the design stage. So design stage helps you define who and what you wanted to experiment on. And then you deploy the code in production, and finally, when you finish running the experiment, you collect the data and you analyze see how your experiment was actually impacting various different metrics, right? So when you are building an A/B test platform, you actually have also very similar 3 components that is very correlated or correspond to these 3 steps that you do when you are running an A/B test. The first one is experiment management. The second one is the online infrastructure. And the third one is the offline analysis. So to see how these 3 components actually work all together, I'm sharing here an architecture from Bing's A/B test system. So as you can see, right, so the end user interact solely with the online infrastructure. When a user comes to Bing's front end, it gets assignment, decided to which experiments or which treatment or control this user actually is going to see. Whereas the experiment owner interact with the experiment management system, which is called control tower at Bing. And also it interacts with the analysis UI, which is what they call scorecards. And I will go into a little bit more depth into each of the three components. So the experiment management system essentially allows you to define the experiments, right? You can decide whom you wanted to target. Do you want it to target people in the US? Or do you want it to target people in China or in Brazil, right? The second walk, it also allows you to decide how you actually wanted to split the traffic, right? Do you want it to go 20% into the new version, which is the treatment, or do you want it to go with 50% even treatment and control? The second aspect is, of course, it should allow you to start and stop an experiment as well. To make it really a more scientific-driven A/B test platform, it should also actually provide you the guidance in terms of how long you should be running your experiment and how you should be actually allocate your traffic so you have enough power or sensitivity to identify the difference that you are looking for. And I will go into a little bit more depth about it later on. Okay, so that's the first component. The second component is the online infrastructure. And for the online infrastructure piece, there's actually three aspects to it as well. First of all, the system should be able to decide how we want it to actually assign users into different treatments, right? So essentially it needs to do the hashing and partition. And the key here is really this needs to be absolutely random. And if a user was seeing the yellow button yesterday, he or she should be consistently seeing the yellow and green button or yellow button today, right? So you want it to be consistent as well. And the concept again is very simple, right? You take the ID, it's either a cookie, it's either a request ID, or at LinkedIn we have member ID, right? You take that ID, you hash it onto this line of numbers, right? So then you essentially partition this line of numbers into different segments and then put each of the segment of numbers into one treatment or into the control. Concept is very simple. The second aspect is deploy. And most common scenario that you will see is that people do deploy on the server side, right? You can also do sort of deploy on the client side or on the browser side, but server side is usually the most efficient one. And essentially, what you're going to do is you treat the experiment as a change to either the default configuration, which is what actually Bing uses, or you treat it as a change to the default code path, which is what at LinkedIn, well, that's what we do. Right? So the third aspect is data logging. Again, very intuitive. You need to log the data, who has seen which experiment, in order for you to do the offline analysis afterwards. Any questions before I dive deeper into each of them? Go ahead.
Hi, at LinkedIn, have you guys ever had the need to, let's say, you ran an experiment. Initially, you have three treatments, A,
Yes.
B, and C.
Mm-hmm.
And it turned out B and C did really well. And you want to put the user in treatment A into B and C and kind of, I guess, reset or redistribute the population.
Yeah.
Do you guys handle it via like a data migration behind the scene, or do you guys do it? I'm sorry, it's great.
It's essentially just configuration driven. At that step, yeah. Yeah, no problem. Any other questions before we move on?
Yeah, so for any of the example that you just introduced previously, for A-B comparison and proving A could be greater than B, right?
Mm-hmm.
So that's being computed from one round of the experiment. And can that be reproducible if you conduct the same experiment at the second time?
That's a great question. So essentially, you're saying that if I see that A is better than B in the first round of experiment, can it be reproducible, right? So the key point of A/B test is that it is reproducible, right? As long as you are doing it right, as long as you are generating the data, as it is trustworthy, right? So we actually expect it that way.
Okay. My concern is when the traffic come in, you have different kind of background of users.
Yes.
It can be young person, can be kids, right? Can be female, can be male. But you treat them as homogeneous population, so you don't differentiate them. So how can you ensure the user coming to your test is going to be the repeatable?
That's a great question. So essentially, how can you make sure that people who are in your experiment are actually representative, right, of the population that you actually wanted to be extending these results to, right? And this, again, comes to me as essentially what is the best practice. And for instance, we discourage people from running experiment for 1 day and then declare success, right? Because for 1 day, you're only capturing the most engaged users who actually comes to your website on a daily basis. But we wanted to make sure that you actually capture at least 1 week for users, right? So there are definitely situations where people are targeting, let's say I'm targeting people who are in Brazil and made my conclusion and I wanted to generalize that conclusion to the entire world. Sorry, it doesn't work that way, right? If you wanted to know about the world's population, you should run an experiment on all populations instead of just focusing on Brazil. Yeah.
Do you ever stratify or run blocks in some sense?
Okay, so when you say stratification, do you mean like that do we do something like focusing on a particular group of particular characteristics of population?
You're A/B testing within strata and then aggregating across strata?
Okay, so we don't do that, but the most situation when you wanted to do stratification is if you have a smaller population and you actually, let's say, have a lot of variance, and then you wanted to make sure that the people who actually are in your experiment in treatment and control are comparable across different strata, right? And then because we have a lot of members, we don't really run into such situations, but I can definitely see that could be potentially an issue for a smaller company.
Besides the metric movement you're looking for, what are the other best practices for treatment size?
We'll go into that.
So going back to your previous example with the Amazon recommendations, so the metric they were looking at to determine success is like revenue, but how do you run multiple experiments at once that have the same?
That's my next slide. Okay, so why don't we move on, and then if we have more questions, we can take it on. This is so that's actually a great question. So essentially, how can we scale, right? So far, I've only showed you, okay, how do you actually do the hashing and partition for one experiment? So what if you have multiple experiments that you actually want to run at the same time? And as a matter of fact, at LinkedIn, we run over 200 experiments simultaneously. How can we handle something like that, right? Okay, so the first model that people use is what I call pure bucket system, right? So this is essentially a system that Google or Bing used quite a few years back. Essentially, the idea is very simple, right? Essentially, instead of partitioning this line of numbers or line of users into only one experiment, you partition it to multiple different experiments. And then you take the traffic that experiment 3 has, for example, and then further partition it into treatment versus control. But given that this is a system that everybody has already abandoned, you know that what's wrong with it, right? First of all, it actually doesn't scale very well, right? Imagine that if we run 200 experiments at the same time, every experiment will only have 0.5% traffic. And that is usually not very many users, right? And the second aspect is that you have to have essentially a central team to control which team or which experiment actually gets how much traffic. They have to coordinate extremely well, right? So the second extreme is essentially what I call them fully overlapping system. So in this case, you can see that every experiment actually gets 100% traffic, right? A single user is actually in multiple experiments simultaneously. And each experiments are entirely orthogonal, and this is essentially controlled by using your unique hash ID between different experiments. So experiments randomizations are totally independent. But the challenge for this system is that you cannot control, if you know, let's say I have 2 experiments, I know that they could interfere with each other. You cannot control for that, right? Because every user is in every single experiment. So what people actually use in industry, in most cases that I know, is really a hybrid version of this pure bucket system and this fully overlapping system, right? And I'm seeing this graph, actually, and also the terminology, layer and domain, from a Google paper back in 2010. So you can see that here, they essentially partitioned this user space, right? And then for this one layer on the right, this everything layer, you can only have one experiment around there, right? So every single user is only in this domain on the rightmost, is only going to see one experiment. Whereas if a user actually lands on something on the left, right, they actually will see 3 experiments at the same time. So even though, by and large, the concept, the hybrid model, is pretty much what everybody uses, the way that teams actually, different companies manage them is actually quite differently. So, and I'm sharing this as an example, at Bing, actually use a very centralized management system. Essentially, there is a central experimentation team that creates and maintains and manages the layers and the domains, right? Whereas at LinkedIn is a very decentralized management, where essentially every experiment creates one layer, right? And the way that you can create a domain, which is essentially a sort of a non-overlapping segment, is through using using hash IDs, and it's entirely controlled by the experiment owners. Okay? Okay, the last aspect in this online infrastructure is about data logging. So I'm not an expert on data logging, but I just wanted to emphasize this one aspect that is super important for experimentation in general, which is really the concept of triggering. So what does trigger mean? Let me share one example, right? So let's say we have, at LinkedIn, we have over 300 million members. But when you're running an experiment on context page, let's say, not every single person at LinkedIn, or not only every single of those 300 million people are going to actually be affected by your experiment, right? Only those who actually visit the context page will be affected by your experiment. So trigger really is the way to identify who actually were affected by your experiment. Okay, and this applies to many experiments in various different domains, right? Imagine that you are at a search engine and you actually made the weather queries so much better. And for your experiment, you are only impacting weather queries. But if I didn't go to Google or Bing and search for weather or a weather query, I was never affected by your algorithm, right? So being able to identify the trigger population is very crucial. So when you are designing a logging system, make sure that it's actually trigger-based logging. Be able to log whether a request is actually affected by the experiment itself. And not only that you're going to log whether somebody actually saw the new green button, you actually also should know that whether somebody is would actually have seen the green button if they were in treatment, even though they were in control. So this is what's called counterfactual. Okay, the third component is the automated offline analysis, right? So, of course, if you wanted your system to scale, it needs to be able to process lots of data, right? As an example, at LinkedIn, as I mentioned, we have over 200 experiments that we process every single day, and we're looking at over 700 metrics, and we're processing billions of triggering events, right? So the second aspect is really about the statistical analysis, right? Make sure that you actually are able to compute the statistical numbers that is p-values or confidence interval and be able to do the t-tests and everything. And we'll go through a little bit more later on. And in order to really help people who run experiments to analyze their experiments, also the platform should not only tell you what have changed, should also be able to help you identify why metrics move the way they do, right? So having that deep dive capability, be able to slice and dice based on maybe people from different country, people with different characteristics, that will be extremely helpful as well. And something that usually gets ignored is the monitoring and alerting. So when you are building a A/B test platform, something that is crucial is to make sure that the numbers are trustworthy, right? So how can you make sure the numbers are trustworthy? Is to essentially build a monitoring and alerting system around it. So when people are looking at the results, they know that they can trust these numbers, they can actually make the right data-driven decision based on the numbers that the platform is providing. Okay, so I'm gonna move to the last topic. How much time do I have? Okay. Okay, so best practices. As I said, right, so education of best practices is actually a very crucial component. And a lot of times, people, even though they could have a platform that's running, but if people cannot make decisions based on the numbers or make the right data-driven decisions, that's all in vain. Okay, so the first one is an example from LinkedIn, again, since I work there. So, unified search. So, I believe that everybody here uses LinkedIn, and if you don't, you should. So, about a year and a half ago, so I'm sure everybody have noticed this, that when we, about a year and a half ago, when you go to LinkedIn and in the search box, when you actually search a query, you have to also tell LinkedIn whether you are looking for a people query, or are you searching a job, or maybe are you searching for a company, right? But now, when you go to LinkedIn and search for a query, it can actually, it's smart enough to tell whether you are looking for a job or a company or a person, right? So this essentially is this unified search feature that was launched about a year and a half ago. But this whole project about unified search was not just about this smart search, this unified search, right? It was actually touching on a lot of various different components. As I'm showing here in this picture, every color block on this page represents a component that was touched. So essentially, every single component on this page was actually changed during this project, right? From the left rail to the right rail, from the snippet to even the pictures and how they lay out and everything, right? So when the team first was doing their A/B test, they lumped everything all together, right? So essentially, the unified search A/B test was doing a, 1 plus 2 plus and all these features all together, compared against what was before the unified search. And guess what happened? The team saw pretty much every single metric tanked, right? And in order to find out why, they had to add one feature back in at a time in order to just reach parity with what it was before the unified search, right? And it turned out that even though this unified search feature was actually extremely successful, people loved it, but because of all the other changes that were lumped in together, they were not able to tell them apart. They were not able to tease the impact from the unified search, from the change on the removal of the bottom ads, or on the change of the left rail and the right rail, right? So really, when you are designing an A/B test, think about how you can set up and design your A/B test such that you can measure one change at a time. Okay, so that essentially is the first piece. Okay, so I said measure, right? So what should you be measuring? So actually, when you run A/B test, you should have a success metric in mind, right? Success metric essentially summarizes whether your treatment is actually doing better than your control. But it's actually very difficult to find or to identify what is the right success metric to use. And for that, I want to share another story. It actually happened when I was at Bing. So the key metrics for Bing, or actually for any search engine, is really to increase the number of searches and also to increase revenue, right? But when we ran this one experiment at Bing, there was a bug, a ranking bug in this experiment. And that experiment didn't do anything else but to rank the really low results on the bottom of the page to the top of the page. And guess what happened to these key metrics?
Search increased.
Sorry?
Search increased.
Search increased. That is absolutely right. Search increased. Because, yeah, people couldn't find what they were looking for, right? And what do you think happened to revenue? Increased. Why?
Because they clicked on the ads because they couldn't find what they wanted.
Right, because the organic search looks horrible. People started to go for the ads, right? So this is exactly what happened. The number of searches went up by 10% and revenue by more than 30%. But does it mean that we should have kept this ranking bug? Of course not, right? I'm sure if we let this run long enough, people will start to be turned away because they couldn't use the product, right? So really, when you are thinking about what to measure in your experiment, really think about these success metrics should not only reflect the short-term impact on users, but really reflecting the long-term. Okay? The next thing I want to share is around scientific experiment design. Really, this is about, as I mentioned earlier, the experiment management system should actually help user decide, the experiment owners decide how long they should be running the experiment and how much traffic they should be allocating to treatment versus control. So why is this so important? Again, I want to share another story. So we all know that site speed matters, right? As a matter of fact, different companies around the industry have run independent A/B tests to show that when you actually slow down the page, you also lower the engagement on the site. But AC.com, when they ran a very similar experiment where they lowered the page load time, they increased the page load time by 200 milliseconds. And their conclusion is that it did not matter. Right? Is it really because AC.com's users are just not sensitive to speed? I don't think so, right? I'm pretty sure if I slow down the page by a minute, people will be turned away. Right? Really, is that I believe they did not have enough sensitivity in their experiment to actually identify the difference that this 200 milliseconds actually brought. Right? In other words, they did not have enough power in their experiment. Right? Power is what I consider as the most important statistical term in A/B tests. Is the chance of detecting the difference when there really is one. So when you're running A/B tests, you don't see anything that's impacted. It could be due to two reasons. One is that you did not have enough power, and then two is that you actually didn't impact anything anyway, right? When your intuition failed. But what we don't want to fall into is really the not enough power scenario, because you don't want the team to spend tons of time, come up with a good creative idea, and development team actually spend tons of time developing this new feature, and end of the day, not having enough power in every test to actually identify that is a great feature. So make sure that you actually properly power up the experiment when you run every test. Okay, statistical significance, the other very important concept. right? So here I'm sharing this real example from 2 experiments we ran at LinkedIn. Of course, I removed all the sensitive aspects to it. So I have 2 experiments, and I'm comparing them side by side on 2 metrics. Right, the numbers that I'm showing you here are the percentage delta comparing treatment versus control. Right, so page views and revenue. So if these are all the information that I'm giving you, which experiment do you think actually has a bigger impact?
2.
Who says 1? Why do you think the first one has a bigger impact? The what? Okay, that's the first time I hear this interpretation. Yeah. Okay. So usually, without me giving you more information, right? If I'm telling you actually revenue, the better, the larger, the better, the page view, the larger, the better, you would actually say, okay, experiment 2 has a bigger impact because the absolute numbers are bigger, right? But what if I tell you that only the 0.8% number is actually statistically significant? Would that have changed your mind?
Yeah.
Right? Exactly. So when we are looking at A/B test, when we are looking at A/B test results, we must consider statistical significance because that is really the only way that we can tell the noise from the signal. Right? Even the 12.9% percentage delta can still just be noise. Okay. It comes to the last best practice. Do you have a question?
Can you talk about the methods you use, like Fisher's test or what's
Okay.
the actual?
So in most cases, the 2-sample t-test is what people use in industry. So essentially, you compare the mean of the 2 buckets.
Okay. You sometimes have like a contingency table, though, like this effect, click or not click. That kind of thing.
I don't think that's necessary. So even because a lot of times, again, I'm talking about when you actually have a decent amount of data, that even though the click and non-click, they could be 0-1 binary data, that the average of the binary data actually also follows a normal distribution. So actually the 2-sample t-test, even though it's simple, it works out pretty well. Any more questions?
How do you know that there's no bias in your significance? Like what if you're introducing something and you have a lot of old users that are used to the old format? How do you know there's not like bias in places with units?
Okay, so you're saying, so the question is, how do I know that there's no bias in my experiment, right? It's a great question. First of all, remember when I say the hashing and partition, that needs to be completely random. And that essentially is our guardian when it comes to how can we ensure the bucket of the users in treatment and control are actually even, right? They were comparable before I even put any treatment effects on them, right? So that is number 1. Number 2 is that even though sometimes we try our best to make sure the randomization all works fine and everything, we still run into situations, maybe there is residual effect, right? Maybe there is some other things that we didn't really realize it was in our system. So what we do is you can actually run AA test. AA test essentially is compared to AB test, essentially is to check whether the user buckets themselves are actually comparable without making any differences in what the treatments really received, right? So the code for A and B buckets are identical. The pure purpose is just to check, is there any bias? You know, are we getting new users in bucket A versus bucket B? Does that answer your question? Okay, we actually only have 5 minutes. So I'm gonna actually go through the last topic and then we'll take questions. Is that okay? Okay, so the last topic I have is about multiple testing. So this is a bit heavy on the statistical terminology side, but I do want to share that because this is extremely important and people actually make a lot of mistakes because of that, right? So there is a very famous comic on jelly beans. I don't know whether folks have seen this before.
Yes.
Okay, some of you guys, okay. But I'm going to share this anyway because not everybody has seen that. Okay, so, okay. So, essentially, somebody come by and say, hey, I heard that jelly beans actually can cause acne. Then the scientists went back and then did one experiment, right? They came back and say, hey, sorry, we found no link between jelly beans and acne because the p-value came out to be greater than 0.05. Then the person is like, wait a minute, I actually heard it's not just jelly beans in general. It's a particular color of jelly beans. Then the scientists went back and did tons of experiments, right? They checked the brown jelly beans, green jelly beans, yellow jelly beans, and everything. And guess what? They found this one green jelly beans that actually has p-value less than 0.05. Celebrate, right? Published in the newspaper saying green jelly beans is linked to acne. Right? You're all laughing, right? Because you think, oh, who does something that's so silly? Okay, and unfortunately, this actually happens quite a lot when people run A/B tests, right? So let me just share the thing that actually happened at LinkedIn. So there's a lot of times when people are actually making comparisons. They're making multiple comparisons. At LinkedIn, when we run A/B tests, we usually start with a low traffic and we slowly ramp up, right? So every ramp, people look at the results and make a decision, right? So there is essentially a multiple testing because you're doing multiple ramps. You're also peeking at the results as it goes along. If I'm running an experiment for 2 weeks, every single day I go check my results, right? You're peeking at the results every single day. Again, you're making multiple comparisons, right? You could also be looking at green, yellow, blue, and maybe just 41 shades of gray, right? And you're looking at so many comparisons as you go along as well. And you're looking at, let's say, at LinkedIn, 700 metrics, right? Of course you run into this multiple testing issue. So our suggestions to people is that when you are ramping up, right, you should really decide or pre-decide a ramp that you should be making your decision based upon. And you should always rely on the full weeks instead of every single day for your A/B test results. And if you're running your experiments based on 41 shades of gray, that's okay. Pick the best, that's okay. But you need to validate and replicate the results in a rerun. And when it comes to multiple metrics, that's a bit more tricky, right? We actually get this question a lot. Is that I see a matrix that's statistically significant and it's irrelevant to my experiment. Like I have nothing to do with that metric. Why did that metric pop up? And first of all, we should understand this kind of how A/B test works when you are doing statistical significance test. Is that if you have 100 metrics, even if your experiment doesn't do anything at all, you will still see at least 5. You see 5 of them come out to be statistically significant because we use 0.05 as a cutoff for p-value, right? So you should be thinking about, okay, so which matrix is actually significant and how significant it is. The way that we tell people usually is to really partition the matrix into these 3 big categories, right? The first order, second order, and the third order matrix. The first order matrix should be the ones that you think are directly impacted by your experiment. So for these ones, you should be still using a 0.05 cutoff for your p-value. But for the second category, which are the ones that may be impacted by your experiment. For example, if you are changing the button color, maybe there is another module on the same page that can be cannibalized by the clicks that you have for your yellow button, right? So that is a secondary metric. And for those, use p-value 0.01. Whereas for the other metrics that you know that absolutely has nothing to do with your experiment, use a much more stringent p-value cutoff, like 0.001. There's actually a very nice connection between the p-value cutoff and how much your prior belief is that this metric is actually going to be impacted by your experiment. Okay, so the last best practice I was going to share is essentially watch out for multiple testing. And I have some references over here that I've used for the talk. And we're actually going to have a blog post for LinkedIn's A/B test platform that's coming up very soon. And also I wanted to advertise, I think Roshan said don't advertise hiring, so I'm not going to do that. But I'm organizing, I'm organizing a A/B test workshop for the conference called Rexis that is actually local in Foster City in October. And we have some really awesome speakers from the industry essentially coming and share their experience about A/B testing in their company, from Google, from Microsoft, from eBay, from Netflix, from SiteSpect. So watch out for that coming up as well. So that's all I have. Thank you. We have time for some questions? Okay.
Can you make truly real time for such kind of operation, and what kind of technology stack you have for that?
Okay, so real time is very nice to have, but when it comes to A/B tests, usually what you try to do is you try to make a decision that, like some of the audience has mentioned, right, that's unbiased for the population that you wanted to actually launch this feature to, right? So real time usually is good for identify if there were issues, but the emphasis when we are building A/B test platform is actually on a daily basis, that we actually generate the results on a daily basis. We don't really do real time.
Hundreds of experiments. Are those experiments essentially siloed? So basically there's no dependency between each of your tests across the board. And if there are dependencies, how do you correct for that? Because if there's pretty high dependency, then if you're seeing some sort of statistically significant result or some metric, you may not be able to tell if it was because of one feature or the other. There might be an interaction. And the third question is, do you use like things like more Bayesian A/B tests at scale? Things like the Bayesian A/B test.
You mean like Bayesian approach?
Yeah, the Bayesian approach, or maybe even multi-arm bandits, like UCD1 or FCD at scale. Okay.
So let me take one question at a time. So the first question is essentially around how can we deal with interactions, right? So if you're running 200 experiments simultaneously, what if there are experiments that are actually interacting with each other, right? How do we manage that? So my experience is that, first of all, interaction does happen, but it happens rarely, right? So usually that shouldn't be the first emphasis if you're building the first A/B test platform for your company. Second aspect is that usually, as I mentioned, the layer and the domain system, usually it can be controlled if the central experimentation team is deciding on who actually goes to which layer. For example, there could be a search UI layer. So any UI experiment on search goes to that layer, so users can only see one search UI experiment at a time, right? So that is one way to essentially avoid interactions. And I know another thing is that if you are using configuration system to deploy your experiment, you can actually check whether these two experiments are actually modifying the same parameter from different experiments. But the other aspect is to make, even if you have let some of these interactions through, is to make sure that you build a system that actually can detect it. So there are methodologies that you can use that can actually give them two experiments to see whether these two experiments actually interact with each other or not. So that's the first question. The second question is around, what, do you remember?
Around Bayesian.
Oh, Bayesian, okay. We don't do much Bayesian for the analysis that we do, other than the fact that I mentioned how there's a very nice connection between using different p-value cutoff for different matrix groups. That essentially there's a very nice Bayesian connection. But other than that, we don't do. I mean, I didn't do Bayesian when I was at Microsoft, and at LinkedIn we don't do Bayesian either. In terms of multi-banded, I wasn't fully impressed by the multi-banded. I guess I probably shouldn't do this publicly. We had a speaker who came to LinkedIn and gave a talk on multi-banded approach, and the issue that the challenge that I see of using multi-banded is really the fact that there's a lot of practical problems when you are doing A/B tests. You can't really treat it as a black box because there are so many things that can go wrong, and there's so many things that needs sort of interpretation. Like I mentioned, right? If in the ranking bug example that I mentioned, if based on the multi-banded, in the short time, you just gonna everybody on the search page will actually see the ranking bug because it's just gonna be ramped up based on this criteria of 10% they've done on search and then 30% they've done revenue. Do we have more time or no?
Let's take it offline. We can do it after.
Yeah, I'll stick around after the talk.
No, after the last page.
All right, thanks, yeah. Okay, I'll actually make this fairly quick. So I'm just going to talk a bit about experimentation at Coursera. So I'm Tom. I lead the analytics group here at Coursera. So the analytics group is a group consisting of both data scientists and data engineers. We're responsible for all the analytics, product analytics support throughout the company, business analytics. We're also responsible for building out data warehousing, experimentation platforms, and things like that. So what I'm going to focus on here is just specifically experimentation at Coursera, and I really only have 2 topics. So first is I'll tell you a bit about where we are today, the state of experimentation at Coursera. What do we actually do with data? And then secondly, I'm going to talk a bit about some of the work that's going on right now in terms of how we plan to advance our experimentation platform. So, experimentation. Let's see here. So where are we today? So today we use experimentation for a number of different things. We use it to improve the student experience. We use it to optimize the website flow in many ways. So for instance, when we're thinking about optimization of the site, we have A/B tests that are running in order to tweak little aspects of the UI and different aspects of the experience. Sometimes we do A/B testing that's actually not on the web. We've done A/B testing through email. So what I've shown here is an example of some A/B tests that we've run where we're trying to make sure that students can have a chance to get back into class after they've been away for a few days or so. So what we did in this particular experiment was we showed different types of emails to different students to uncover what were the things that are important, what are the elements that really draw a student back into a course. We do other things as well. We use A/B testing not just simply for the experience, but also for thinking about product strategy. So this is an example of, some of you may be familiar with Coursera's Specializations. So Specializations is a program in which we string together sequences of courses, as well as some type of capstone project. And if you complete all of these, then you get what is known as a specialization certificate. And before we introduced this product, one of the things that we actually did was we ran an A/B tested survey where we described different types of potential products in order to see what products might people actually be interested in and which ones actually show real effects. We had a lot of different ideas, but it turns out that only one idea really was actually very impactful in dramatically increasing user demand, but I'll leave you guessing as to what that is. So overall today, we use it for a number of things: optimizing product flow on the web, we A/B test through emails, we look at product strategy. Where are we going with A/B testing? So one of the things that we've started this quarter in particular is we've actually started to think about what is the next generation of our A/B testing platform. So our current A/B testing platform is something that we threw together in a couple of weeks about a year and a half ago. We thought that, it was probably the most high leverage thing that we could do under a limited budget of time. But now it's time to really up our game. So a couple things. So one is we want to make sure that our A/B testing extends to more platforms than simply just the web. Our JavaScript A/B testing client library is just not enough. We want to be able to support new platforms such as mobile. We want to be able to support things like incremental rollout and deployment. We also have, a pretty janky A/B testing reporting system today. This is not the most beautiful thing in the world, but hey, it works. And in order to really leverage and incorporate metrics, we want to integrate it with our data warehouse. And so this is just kind of a schema diagram that shows you, everything that's in our data warehouse today. But once we can actually hook up our A/B testing to our data warehouse, then we'll be able to access tons more deeper metrics than we can actually measure today using our simple metrics. We also have quite a lot of different types of users and a lot of different types of courses on our platform. There's quite a bit of heterogeneity. And so what this here is just, a whole bunch of age distributions for different courses. And you can see that, there are courses that vary all over the place. I think a lot of young folks seem to think that machine learning is really hip, and then at some point you realize statistics is very important. Late in life, perhaps poetry and philosophy are important. But actually there are also the young people who think that philosophy is very important too. So, but the basic idea is we have a lot of different types of courses, a lot of different types of students. And so it's not clear that the interventions that work for one group of students works correctly for another group of students, maybe because of their age group, maybe because of their demographics, but also potentially because of the type of subject matter that they're participating in. And then finally, beyond the things I've said so far, we actually have a number of different university partners that we work with, over 100 university partners today. And at these institutions, they have a lot of academic researchers who are also interested in advancing the state of pedagogy. Okay? And so one of the things that they're very interested in is being able to actually run A/B tests themselves, figuring out ways to improve the material. How can we make better lectures? Okay? So being able to create a system that is ready for mobile, allows incremental rollout, has improved administration and reporting, integrates well with our data warehouse, allows us to account for effect heterogeneity through things like targeting, through things like post-stratification of results, or also preparing our A/B testing system for external consumption. These are things that we're all looking towards now. And so I'd like to just end with a couple things. I'd like to thank y'all one more time for coming and telling us how we built this platform. Thanks very much. And then finally, thank you all for coming. I think Roshan didn't tell me not to talk about hiring. So, we are hiring. But thanks for coming, and please come again to another one of these talk sessions. Good night.